So our next speaker is Ryan Snyder. Ryan is a graduate student completing his PhD in Dr. John Barta's lab at the OVC. He is primarily focused on commercial broiler chicken coccidiosis control strategies, improving anti-coccidial drug sensitivity, and developing DNA tools to identify and quantify Amira species.
Thank you for the introduction, and if you guys weren't sick of me already, you got me for another 15 minutes. I'm not quite sure what the organizers were thinking when they asked me to come up here, but here I am and you're stuck with me now. What I'm going to be talking about today isn't, for this presentation, isn't going to be too much different from what you've heard earlier today. It's all about getting chicks off to the right start. Keeping your cocci content does come into that equation. But we'll just talk first about the disease, coccidiosis. It's problematic in vaccinated flocks, not always, between 2 to 3 weeks. That's the prime time for necrotic enteritis infection. We also have medicated flocks, and their highest challenge, not necessarily clinical or even subclinical infection, but their highest challenge would be 4 to 5 weeks of age, and this is going to be a bigger hit on metabolism. So you can see those two groups aren't really affected by coccidiosis in the first 7 days. Okay, good speech. Thank you. So when we're talking about coccidiosis, we do have several different myriad species that we're working with, and they all infect different parts of the intestinal tract. They are mostly an issue for younger animals, and so really when it comes down to the first 7 days, it is important to really take a look at them, at these parasites and this disease. It is an artificial disease, so it wasn't really an issue when the birds were wild and they had a very low density for birds per area. And as mentioned, this can predispose to necrotic enteritis. Coccidiosis research is not slowing down. Since the first publication that I found in 1910, this is just searching the word coccidiosis in Web of Science, and it's just skyrocketed ever since. And if you look at 180 per year, that's almost a coccidiosis-related paper every other day. So why is that? It's because we've created an Amira heaven, or haven as you want to call it, and it comes down to that artificial disease that I mentioned before. So this room has thousands of hosts, all the same age, they're all young, they all have access to their feces, and this is just the perfect conditions for Amira to flourish. Backwards, if we go backwards, looking at the first few days of the bird's life, this environment isn't so much ready for a big cocci infection yet, but it's going to be soon, and we need to kind of manage for that properly. And looking at these birds, it's a nice warm environment. They're spreading across the barn. These birds are about 3 days old, and they're starting to find the food and water on the other side. And it's interesting to think about the comfort zone that Dr. Gillingham had mentioned earlier. So what's involved in our cocci infection? Well, we're going to need 3 things, and we're going to go through each of those. We need the parasite to be involved, obviously. We need the host to be there, and we're also going to need the proper environment for the parasite to be there and to cause an infection. So let's go through each of these. The first is the parasite. These are single-celled parasites. They're different than bacteria. They're virtually everywhere that a chicken barn is found. So if you want to build a chicken barn up in space, you're going to find Amira there. And they have this environmentally resistant oocyst wall, which is really unaffected by disinfectants. So between flocks and in barns, these oocysts just find a way to hide. They can't really get washed away that well. We can remove the litter, we can reduce the load, and we're going to talk about the exposure in the environment in a bit. And they have a specific life cycle where they have to go inside and out of the host. So let's talk a little bit about that life cycle. In the environment, we need oxygen. Sorry, I should let you guys read that. Oxygen is required in order for sporulation to occur. This allows the parasite to become effective in the environment. We also need moisture, so these oocysts can dry out, so we need to make sure that there's a good relative humidity. If they get too low, they dry out, then the parasite can essentially die or not advance to the next stage. We also need temperature, and oocysts are susceptible to freezing. So the oxygen and the temperature are pretty easy because we need to have birds with oxygen in the right temperature. So we're going to be having 2 of these basically at all times that the chickens are in the barn, but it comes down to the moisture in order for the parasites to start cycling. So let's take a look at the host, the broilers, and I'll go through each of the different types of birds here. So broilers, they've got a relatively short production cycle. They're not crammed, but they are high density compared to the other bird groups. They are selected to have great potential and pressure to grow very quickly. So they're just pumping the feed through them in order to grow as fast as they can. So this is going to add a little bit of pressure and stress on the birds. They are floor reared, which becomes important because they do have access to their feces. And with broilers, we have two options, anti-coccidials or live vaccination. And we're going to get into that in a little bit. When we look at layers of breeders, in contrast to broilers, it's more of a longer production cycle. So vaccination is a more economical option here. Dr. Petrick mentioned this morning about using anti-coccidials in the past during the pullet phase. We wouldn't really want to be using those during the egg laying phase because of any material that could get transferred down to the egg. So really, vaccination is going to be one of the most commonly used options for controlling coccidiosis in these birds. And Dr. Petrick also mentioned the system that they're raised in. So it's either aviary or enriched or even conventional cages. So depending on if they have access to their feces or not, that's going to depend on how we're managing the area. And the times that anti-coccidials are used is usually for treatment of outbreaks. Turkeys are kind of a unique blend, I find, between our broilers and our layers. They are still reared on the floor, but they're more long-lived, so they have a little bit more time to develop immunity and more compensatory growth before they go out to market. Both immunological or vaccine or anti-coccidial control is used as far as I'm aware of. I have heard that more turkey farmers are going to just using the vaccine and that the anti-coccidials are used less and less, but that may depend on the processor that you're working with. Also looking at the host, we need to take into consideration the immune system. And so when the birds are 7 days old or even less, the immune system isn't really working yet, and at least it's not going to be protecting them from an Amiri infection because they need multiple exposures, as Dr. Petrick mentioned earlier. So they do have maternal antibodies that are going to be protecting them from some infections. That's going to kind of help the vaccine work its way through. But for the most part, the immune system in a cocci world isn't really totally suppressing an infection. And so if you can't beat them, join them, or just try beating them harder, and which kind of comes into play when we're talking about anti-coccidials. And we have two different groups, either chemical or ionophorous anti-coccidials. The ionophores do have antimicrobial properties, so it's possible that we may not have these options to control for coccidiosis in the future if we do ever go fully RWA. But right now they're category 4, so we will have them for the foreseeable future. The chemical anti-coccidials have been along for a really long time, and they have certain levels of sensitivity. And so when you're using these drugs, it's recommended to be looking at your programs, what drug's working for you, make sure you rotate throughout the season, and make sure you're shuttling within a flock, and that way you'll have your best coccidiosis control program. So now shifting over to the environment, what do we see when we look at this picture? We see birds that are brooded. We've got a chick guard. These are turkeys here. And we see supplemental feeders and drinkers so that they have access to all the things that they need. Comes down to the flaws that Dr. Gillingham talked about earlier. And they're corralled, one, because sometimes they get lost and can't find their way back to feed and water. So it's nice to keep them in there, but that's also going to help with the vaccine. So having the right density of birds in an area is going to allow for the promotion of shedding, sporulating of the oocysts, and then re-ingestion of the oocysts, especially in a vaccinated situation. So looking at the environment, and then we can kind of still split this into two situations. Are we using anti-coccidial drugs, or are we using the vaccine? My question, and I don't know if I'll ever be able to answer this, is where's the first oocyst come from? Is it on the feed lines, drinker lines? Is it up on the fan or the heaters? Is it on the dust up there that when the birds get old enough it falls down? Is it on the feed? Is it, I don't know. I don't suspect it's in the feed. I should probably say that so the feed mills don't come after me. But it's got to be coming from somewhere. And so we find anti-coccidial programs still shedding oocysts 3, 4, 5 weeks out of age. So they're there. So on the other hand, vaccination provides a uniform exposure. So basically as many of the birds as we can reach, where they're all getting specific exposure at the right age. And this is going to be kind of better for the whole flock coccidiosis dynamics so that they're all at the same immune status. Whereas when you're on the anti-coccidial program, this bird gets a little bit here, then a few days later the next bird gets it. Having everybody at the same time just allows for better uniformity of the bird's growth. But when we do talk about the vaccine, we do need to ensure that they cycle properly on the farm. And so for those of you who have seen the slide before, I apologize, but it is important. We do need to be managing our flocks properly. What happens is after vaccination, we need, and Dr. Petrick mentioned this, the oocysts are going to work in the gut, they're going to infect the bird, and then they're going to come out the other end, and we need re-ingestion. We need these multiple exposures in order for the birds to develop their immunity. After a while, they will become immune and start shedding fewer and fewer oocysts, and that's when they're immune to the species that were in the vaccine, and then they're no longer susceptible to those infections. And so it really does come down to this whole cycle starts off at the beginning, application and making sure we've got the right environment. And so it's all about balance. When we're looking at getting the best environment for the Cocci, on the scale of relative humidity from 0 to 100%, I hope you don't ever have 100% because it'd be raining in your barn. But if you're at 0%, you've got a really dry environment, and the oocysts just aren't going to sporulate, and so your birds are not protected, and there's no anticoccidial in the feed, so you are at risk of an outbreak later. On the other side, if you are at the almost saturated situation, yeah, you'll get your sporulation, you'll get reinfection. However, now you have wet litter. Okay, so I'll mention this is relative humidity, not litter moisture. And when you get really high relative humidity, we're going to have high litter moisture, and that's when it just promotes bacterial growth. So we want to avoid that. So basically, I don't know the sweet spot. I would say around 40 to 60% relative humidity, and this is most important when the birds are shedding the oocysts about 5 to 8 days of age. Prior to that, you can keep it dry. After that, you would want to still keep the moisture in there for a while, but by the time the birds are 3 weeks of age, you can start clearing out that humidity as best you can. Yeah, and so if you want to say 6% relative humidity, then your litter moisture is around 30%. So in summary, we need the proper brooding in order for the Coccidia to develop, for the birds to become immune. And this is most important for chickens or turkeys under their coccidiosis control programs. It comes down to management on the farm. How are you managing your heaters, your ventilation, even your drinkers? If they're too low and they're just pecking and playing with the drinker lines, you're going to have wet litter. We do need to take density into consideration, and again, relative humidity without our wet litter. And when it comes down to it, we do need proper nutrition. We want to start developing the gut health and the immune system as fast as we can. I normally have my head up in the clouds, but this one just kind of struck me as that it is a chicken. It was pretty cool. With that, I'd be happy to take any questions.